Here's another example of binomial distribution. You have a spinner. It's divided into 5 equal sections. 2 of the sections are marked with a 1 and the others are marked 2, 3, and 4. If we spin the spinner 4 times, and if we define x as the number of ones spun on the spinner, then x is going to have a binomial distribution where n is 4 and the probability of success p is 0.4 because it's 2 ones out of the 5 sections. And the probability of spinning a 1 on any trial would be 2 out of 5. Now the probability distribution of x in this case we can figure out similarly to the previous video. We start with a choose, and then we have a probability of success to some power and a probability of failure to some power. All the probabilities are like this. If we have no successes, then the choose would be 4, choose 0. And we'd have 0.4, the probability of success, to the 0 power, and 1 minus that, 0.6, to the 4th power. And then we could ask our calculator what that is. It's 0.1296. So all these probabilities have this kind of structure. There's a choose, there is a probability of success raised to a power, there's a probability of failure raised to a power. These two powers have to add up to the number of trials. And then this power here on the probability of success is the same as the number of successes in the bottom here. So when we do the probability that x is 1, we'll do 4, choose 1. That success can come anywhere in the string of 4 trials. And we have 1 success, so the probability of that would be 0.4 to the 1. And then we'd have 0.6 to the 3rd. So the exponents add up to 4. And we have the probability of success here, probability of failure here. And when we multiply all that together, we get 0.345. If we look at 2 successes, we'll have 4 choose 2 ways that those successes could occur in the string of 4 trials. And then we have the probability of success to the 2nd power, because success is happening twice, and the probability of failure to the 2nd power, because failure is happening twice. And when we multiply that together, we get 0.3456 for that probability. Here are a couple more. You can finish this. Follow the same pattern. We're just increasing the bottom number in these chooses by 1 each time. We're increasing the exponent on the probability of success by 1 each time, and we're decreasing the exponent on the probability of failure by 1 each time. So you can pause the video and figure these out, and we'll come back in a minute. Okay, we're back. The probability of getting 3 successes in 4 trials will be 4 choose 3 times 0.4 to the 3rd power times 0.6 to the 1st power. That is 0.1536. And then the probability of getting 4 successes will be 4 choose 4. That's just 1 times 0.4 to the 4th power times 0.6 to the 0 power, and that's 1. So this is really just 0.4 to the 4th power, probability of success multiplied times itself, so that we have 4 of those multiplied together. That works out to be 0.0256. So you see a pattern in all these probabilities. We start with a choose that tells you how many ways we can get this number of successes in the string of n trials, and then we have the probability of success raised to a power. That power is equal to the number of successes we're interested in, times the probability of failure raised to whatever power, this power right here, subtracted from n. So this would be 4 minus 0, which is 4. This would be 4 minus 1, which is 3. 4 minus 2 is 2. 4 minus 3 is 1. 4 minus 4 is 0. So these step down as these are stepping up. So there's a general probability formula that applies to binomial distributions, and it looks like this. If x has a binomial distribution with n trials and a probability p of success, then the probability that x equals some number k is n choose k times p to the k power times 1 minus p to the n minus k power. Here's an example of that. If n is 8 and p is 0.2, then the probability that x is 3, this right here, is k. We have enough information to plug everything in here that we need. We're going to take 8, choose 3, number of trials, number of successes, 8, choose 3, times 0.2 to the number of successes, in this case 3, and 1 minus 0.2 to the 8 minus 3 power. So this is basically 0.8 to the 5th power because we have 3 successes and 5 failures in this event. And that's what those 3 parts of the formula are equal to. And that's 0.1468. When n is 7 and p is 0.6, and if we're interested in the probability of success of getting 4 successes, k would be 4. So we'd have 7 choose 4, that's n choose k, times p, 0.6, to the k power, 4, times 1 minus 0.6, probability of failure there, to the 7 minus 4 power, or the n minus k power. And those work out to be 35.1296 and 0.064. Multiply them together, you get 0.2903. And here are a couple more. We'll leave as much of that up on the screen as we can. And here are a couple you can try on your own, so you can pause the video and figure those out, and we'll be right back. Okay, we're back. If x equals 5 and n equals 6, or k equals 5, and n equals 6 and p equals 0.8, we're looking at 6 choose 5 times 0.8 to the 5th power times 1 minus 0.8, which is 0.2, to the 1st power. And that is approximately 0.3932. And then if n is 10, p is 0.3, and k in this case is 4, we're going to take 10, choose 4, times 0.3 to the 4th power, times 0.7 to the 6th power, and that's going to be approximately 0.2001. Now, binomial distributions, they're probability distributions for a random variable. It's a discrete random variable. You can take values between 0 and n, and just integer values between 0 and n. But any probability distribution has a mean and a standard deviation, and if we want to find those things, this is how we do it. The mean is quite simple. It's just n times p. The logic behind that is that if you try n times and you have a proportion p of successes, you just multiply that proportion times the number of times you try, and that's how many times you'd expect to succeed. So this mean is the expected number of successes in your n trials. Standard deviation is a little bit more complicated, but not too much. Square root of n times p times 1 minus p. Here's an example. If n is 8 and p is 0.2, the mean is np, which is 8 times 0.2, or 1.6. Standard deviation is the square root of n times p times 1 minus p. Square root of 8 times 0.2 times 0.8. All that stuff under the radical is 1.28, and the square root of 1.28 is about 1.1314. If we have 7 trials and a probability of success 0.6, on average, if we did this many times, we'd expect to have 4.2 successes in our many attempts at this particular situation. N times p, 7 times 0.6, 4.2. The standard deviation is the square root of n times p times 1 minus p. It will be the square root of 7 times 0.6 times 0.4, which is the square root of 1.68, or 1.2961 approximately. Here are a couple more. You can try these on your own. Just plug in the values of n and p in the appropriate places in the formulas, and you can pause your video and figure those out, and we'll come right back. Okay, welcome back. On this one, where n is 6 and p is 0.8, np is just going to be 6 times 0.8, and your mean is 4.8. Your standard deviation is the square root of 6 times 0.8 times 0.2. That is the square root of 0.96, and that is approximately 0.9798. On the second one here, number 10, if n is 10 and p is 0.3, then the expected number of successes would be 10 times 0.3, or 3, and the standard deviation of the number of successes would be the square root of 10 times 0.3 times 0.7. That is the square root of 2.1, which is approximately 1.4491. These formulas for the mean and standard deviation are going to be very important in what we're going to do next, and it'd be good to memorize them and practice them as much as you need.